Perform the following operations using exponent rules and then write in standard notation. A lot of people try to convert the numbers to standard notation first and then do the operation, but that tends to be harder to keep track of the place values. So it's easier to actually do these operations in the scientific notation and then convert to standard notation. And how we're going to do that is, remember, it looks like an X, but it is multiplication. So this is all multiplication. All of these are being multiplied, and that means we can use the commutative and associative properties of multiplication. So I'm going to multiply 7.3 times 8. And I'm going to multiply 10 to the negative 2 times 10 to the 5th. I'm going to associate those factors, those like factors, together. Because I can multiply 7.3 times 8, and that's going to give me one decimal place, so 58.4. And I can multiply the base 10s. So I keep that base and I add the exponents. Negative 2 plus 5 gets me an exponent of 3. So this is our answer in scientific notation. If we want to change this to standard notation, we're going to be moving the decimal to the right 3 places and add in zeros for those place values, making this 58,400. In our next example, we've got division, but division is just multiplication of the reciprocal, so multiplication rules apply if we associate like factors. So 1.2 divided by 4 and 10 to the 4th divided by 10 to the 9th. Okay, so 1.2 divided by 4, 12 divided by 4 is 3, and there's one decimal place. Then 10 to the 4th divided by 10 to the 9th, we'll use the quotient rule, so numerator exponent minus denominator. And that's going to be 4 minus 9 is negative 5. So this is our answer in scientific notation. We're going to move the decimal to the left 5 places. 1, 2, 3, 4, 5. Fill in those holes with zeros. And that means our answer is 0.50 in standard notation. How can we decide which of these numbers is larger? Which is a larger number? So if we just look at the base A here in the scientific notation, it looks like 7 is larger than 2. Should we stop there? No, because this is actually going to be a smaller number because it only has 3 place values after the decimal. So if we move that 1, 2, 3, that's going to be 7,000. But this number has 5. If we move that 5 place values, that's going to be 4 zeros, a 1, 2, 3, 4. So that's 210,000. So that's the way we need to look at these, is whatever has the highest number of place values after the decimal. In the second example, if you just compare the base A's, 9 is bigger, but it has a negative exponent. That means you're losing a place value. So this is definitely going to be a larger number here.